You know that feeling when you look at your phone storage and realize you have something like 15,000 photos?
Oh, yeah.
Mostly memes from 3 years ago,
Oh.
blurry screenshots of recipes you never cooked, and videos you don't even remember taking.
Painfully familiar. And you just keep buying more cloud storage because, I mean, the alternative is actually sorting through it all.
Yeah, take that anxiety and multiply it by, I don't know, 1,000,000. Imagine you aren't just a person with a phone. You're a global media company.
Right?
You aren't dealing with gigabytes. You're dealing with petabytes. We are talking millions of customer invoices, hours of uncompressed 8K video, server logs that just scroll into infinity.
And massive data sets for machine learning. And unlike your phone, you can't just hit delete all or, ignore it.
Exactly. You have compliance laws, customer demands, and analytics engines that need to eat. And this brings us to the data swamp. How do you store all this massive, unstructured stuff without going broke or losing your mind?
And that is the mission for today's deep dive.
It is. We are tearing apart the documentation on Azure Blob Storage.
We're going to move past the sales pitch and look at the actual architecture. We've got data here on the strict hierarchy of containers, the dangerously confusing pricing models for access tiers, and the automation tools that stop you from having to manage files manually.
And we need to answer the big question. Is cloud storage just a hard drive in the sky, or is it something smarter?
Let's find out.
So let's start with the name, Azure Blob Storage. It's a fun word, blob.
Yeah.
But it actually means something specific in computer science, doesn't it?
It does, yeah. It stands for binary large object.
Which sounds like what I see in the mirror after a holiday weekend.
Tech naming conventions are rarely flattering, but the distinction here is important because it tells you what this service is not.
Okay.
Think about a SQL database. That's structured. Rows, columns, rigid data types. If you try to shove a 4K video file into a spreadsheet cell, things just break.
Right. A spreadsheet expects a date or a number, not a movie.
Exactly. A blob is for unstructured data, text files, JPEGs, MP4s, stubborn application installers, backups. It doesn't have a predefined model. It's just data.
It's the catch-all drawer for the digital world.
That's a good way to put it, the junk drawer.
So if I'm dumping millions of files into Azure, I can't just have them floating in a void. How is this actually organized? Because the documentation mentions a pretty specific hierarchy.
It's a 3-layer cake. At the very top, you have the storage account. That's your namespace. It's the unique address for your data on the internet.
Think of it as the address of the apartment building.
Perfect. Inside that account, you have containers. These act like folders, but with a catch.
Okay.
You cannot have a blob floating loose in a storage account. It must reside inside a container.
So no stray files on the desktop. Everything has to be in a bin.
Precisely.
Right.
And then inside the containers, you have the blobs themselves, the actual files.
I want to pause on containers for a second. In a standard file system, like on my laptop, I can have folders inside folders. I can nest things 20 layers deep.
Right. That's a hierarchical file system.
Does blob storage work the same way? Can I have a container inside a container?
No. And this is where people get tripped up.
Oh.
Visually, if you look at the Azure portal or a browser, it might look like there are folders. You might see a path that says, Photos 2024 January image.jpg.
That looks like a folder structure to me.
It's an illusion. Blob storage uses a flat namespace.
A flat namespace.
The forward slashes are actually just part of the file name. The system renders it to look like folders for our human brains, but technically it's just one massive bucket of items with very long names.
Wait, really? So 2024 isn't a folder, it's just a prefix on the file name.
Correct.
That feels like a subtle distinction, but why does it matter to me?
It changes how you search and list files. If you want to move a folder with 10,000 items in it, in a normal system, you just move the folder.
But in a flat namespace.
You're technically renaming 10,000 individual blobs. It has real performance implications.
Okay, that is good to know. Let's talk about security before we start filling these containers. By default, if I create a new container and upload a sensitive contract, who can see it?
By default, it's private. No anonymous access. Only the account owner has the keys.
Okay, good. But I've seen options to open that up.
You have 3 levels, essentially. Private, which is the default. Then you have blob access. This means anonymous users can read a specific file if they have the direct link.
But they can't browse the container to see what else is in there.
Exactly. That's really useful for hosting images for a website.
Mm-hmm.
And then there is container-level access. This is the one to be careful with. It allows public reading and listing.
So someone can see the file, but they can also ask the system, show me everything else in this bucket.
Which is a recipe for a data leak if you aren't paying attention. We've seen headlines about unsecured buckets for years. Usually it's someone setting container access when they really meant to set blob access.
So double check your settings.
Got it. Now, I want to get into the economics of this, because the sources emphasize that Azure Blob Storage isn't just one price. It's a menu.
The access tiers. This is where you either save a fortune or accidentally bankrupt your department.
Because data has a temperature, right?
It does. Microsoft categorizes this into 4 tiers: hot, cool, cold, and archive. And the game is balancing 2 variables: storage cost versus access cost. I like analogies. Break this down for us.
Okay, think of it like real estate versus toll roads.
I'm listening.
The hot tier is prime real estate in the city center. The rent, the storage cost is the highest. You are paying a premium to live there. But the toll roads to get to your house are free or very cheap. Access costs, reading and writing data are rock bottom.
So if I have a viral video that is being streamed 10,000 times an hour, I want it in the city center.
Absolutely. You pay high rent, but you save massive amounts on the transaction fees because you are accessing it constantly.
Okay, moving down. Cool tier.
This is the suburbs. The rent is lower. The storage cost drops significantly. But every time you drive home, you pay a toll.
The transaction cost to touch the file goes up.
It does, and there's a minimum lease term.
Ooh.
Yes. The documentation defines cool data as staying for at least 30 days. Think short-term backups or the raw footage from a project you finished last month.
So if I delete it after 5 days...
You get charged an early dilution fee. You pay for the 25 days you didn't use.
Ouch. Okay. Then we have the cold tier. This feels like the awkward middle child.
It sits between cool and archive. It's for data that is rarely accessed but needs to be available instantly if requested. The minimum stay here is 90 days, even cheaper rent, even higher tolls.
But the real beast, and the one I have questions about, is the archive tier.
The deep freeze.
The rent here is pennies? Right.
Fractions of a penny. It is incredibly cheap to store data here. This is for compliance logs from 5 years ago or primary backup tapes you hope to never need.
But here's the catch. It's offline. What does offline actually mean in a cloud context? Is someone, like, taking a hard drive out of a server and putting it on a shelf?
Effectively, yes. It might be on a tape drive or a powered-down disk system. The point is, if you click download, nothing happens. You cannot read a blob in the archive tier immediately.
So if the CEO needs that file right now for a legal discovery meeting and it's in archive?
The CEO is going to wait. You have to rehydrate the blob. You submit a request to move it back to a hot or cool tier.
And how long does that take?
Depending on the priority you pay for, it can take anywhere from an hour up to 15 hours.
15 hours. That is an eternity in the digital world. And there is a 180-day minimum commitment.
6 months. If you rehydrate it after 2 days, you are paying the early deletion penalty for the remaining 178 days.
So the strategy here is really about predicting the future. You have to guess how popular a file will be.
And humans are terrible at that.
We are. I can't look at a million files and manually tag them. Okay, this invoice is boring. Move to cold. This meme is funny. Keep it hot. It's impossible.
No human could manage that. And that's why lifecycle management is so critical. This is what allows you to automate the chaos.
How does that work in practice?
It uses rule-based policies. Basically, huge if-then blocks that run in the background.
Walk me through a typical policy.
You might set a rule that says, look at all blobs in the logs container. If a file hasn't been modified in 30 days, then move it to cool storage.
And you can chain these.
Yes, you can create a flow. If it's older than 30 days, move to cool. If it's older than 90 days, move to cold. If it's older than 365 days, move to archive. And if it's older than 7 years, delete.
That is incredibly powerful. It basically turns the storage account into a self-cleaning system.
It moves the data from expensive tiers to cheap tiers as demand drops without you lifting a finger.
But wait, I see a trap here. Automation is great, but what if I set a rule to archive everything older than a year? Because I assume nobody looks at it.
Okay.
But then suddenly we get audited, or we decide to train an AI model on our old data, and we need to read all those files.
You just walked into a financial nightmare.
Right, because of the rehydration cost.
Exactly. If your automation moves 1 million files to archive to save you, say, $500 a month, and then you realize, oops, I need to read those, you have to pay the rehydration cost and the expensive access fees for every single one of those 1 million files.
It could cost way more than the storage savings you made in the first place.
It absolutely could. You have to verify your logic before you unleash the automation. You don't want to accidentally freeze your assets.
So automation is a sharp tool. Don't cut yourself. Let's pivot to keeping this data safe. We talked about tiers, But what about redundancy?
Right, so Microsoft offers different levels. You have LRS local redundancy, where they copy your data 3 times within the same building. That protects against a hard drive failure.
But not against a fire or a flood.
Right. For that, you go up to geo-redundancy, where they copy your data to a completely different region, say East US to West Europe.
But the outline specifically mentions object replication. How is that different from just clicking the geo-redundancy checkbox?
This is a key distinction. Geo-redundancy is primarily a disaster recovery solution. It's a failover. You don't really touch the backup unless the primary region goes dark.
I see.
Object replication is active. It asynchronously copies specific blobs from a source container to a destination container while both are running.
Why would I do that, aside from just being paranoid?
Performance and latency. Imagine you have a team in New York and a team in London working on the same large video files.
If the London team has to download from New York every time, it's slow. The speed of light is only so fast.
Exactly. With object replication, you have the New York container automatically copy new files to a London container. The London team hits their local copy. It's fast.
It's like having a local cache.
And it also helps with compute load. You might have a heavy AI processing job running in one region, and you don't want it slowing down the analytics job in another. They can work off separate copies.
Is there a prerequisite for this? It sounds complicated to set up.
The big one is versioning. You must enable versioning on both the source and destination accounts.
What does versioning do?
It keeps a history. If you overwrite a file, Azure keeps the previous copy saved as a version. Object replication needs this to track changes and ensure the right data gets across.
Any limitations we should know about?
One specific note from the text: snapshots are not supported in object replication. If your workflow relies heavily on manual snapshots, you need to be aware of that.
Okay, we've covered structure, tiers, and replication. But we've been using the word blob as a generic term. The documentation points out that there are actually different types of blobs.
Correct. It's not a one-size-fits-all situation. There are 3 main types you need to know. First, the block blob.
Block blobs.
This is the default. It's made of blocks of data assembled together. This is what you use for text, images, videos, standard files. It's probably 90% of what listeners will use.
Then why do we need append blobs?
Imagine a logging file. A server is writing an error report every second.
Okay.
If you use a block blob, every time you add a line, the system has to process that block. It can be inefficient for constant adding.
Ah, I see.
An append blob is optimized to just tack data onto the end instantly. It's built for high-volume logging, where you never delete or change the middle, you just add to the tail.
And the third one, page blobs.
These are the heavy lifters. They can be huge, up to 8 terabytes. They are optimized for random read-write operations.
Random read-write. Translate that for the non-computer scientists.
Think of a video file. You usually watch it from start to finish. That's sequential.
Yeah.
Now think of the hard drive running your computer operating system.
It jumps around.
Right. It reads a system file here, writes a temp file there, checks the registry over here. It's chaotic.
So page blobs are designed to handle that chaos.
Exactly. That's why they are used to back Azure virtual machine disks. If you spin up a server in the cloud, its C drive is technically a page blob.
Okay, that makes sense. So we know what we are storing and where.
Yeah.
How do we actually get the data in? If I have a few Word docs, I assume I just use the web portal.
The Azure portal.
Yeah.
Drag and drop. Easy.
But what if I have a terabyte of messy data? I feel like the web browser is going to crash if I try to drag a terabyte folder into it.
It absolutely will. For managing larger resources, the source suggests Azure Storage Explorer. It's a desktop application. It looks a bit like File Explorer on Windows or Finder on Mac.
So it's more stable.
Much more.
Right.
It handles failures better, lets you manage permissions, and is just more robust for day-to-day management.
And for the hardcore techies, the ones who hate using a mouse.
As this could be.
I hear this name all the time in cloud circles.
It's the gold standard for bulk movement. It's a command line tool. You type a script, hit enter, and it moves mountains of data. It's highly efficient, and importantly, it's restartable.
So if my internet cuts out halfway through a 500 gigabyte upload,
His copy picks up right where it left off. You don't have to start over from zero.
now here's a scenario I love.
Wow.
What if I have so much data, let's say 500 terabytes sitting in a legacy data center, that uploading it over the internet would literally take 3 years?
That is a very real problem. We call it the bandwidth limit. There's an old saying: never underestimate the bandwidth of a station wagon full of tapes driving down the highway.
Is that still a real solution in the 2020s?
In Azure, it's called the data box.
Tell me how this works.
You literally go into the portal and order it like a pizza. Microsoft ships a ruggedized case to your data center. It has massive solid-state drives inside.
A physical box.
You plug it into your local network, copy your data onto it at super fast local speeds, no internet required. Then you unplug it, call the courier, and ship it back to Microsoft.
And they plug it in on their end.
And upload it directly into your Blob storage account.
It is hilarious to me that in the age of fiber optics and 5G, sometimes the fastest way to move data is a FedEx truck.
Physics is physics. Sometimes the truck wins.
Before we wrap up, we have to talk about the part everyone dreads but needs to understand. The bill.
Pricing.
We mentioned the tiers impact the price, but the sources have some specific warnings about hidden costs.
The Azure pricing calculator is the tool you'd use to estimate this, but you have to know what inputs to give it. It's not just how much space do I use.
Right. We touched on this with the real estate analogy, the tolls.
The technical term is operations. Every time you list a container, read a file, write a file, or check a file's properties, that is an operation, and you are billed for them.
Give me a nightmare scenario where this goes wrong.
Okay, you have an application that writes millions of tiny 1 kilobyte log files every day. You decide to move them to the cool tier to save on storage costs.
Sounds smart. Storage is cheaper there.
But the write operation cost in the cool tier is double or triple the hot tier. Because you are doing millions of transactions, you might save $10 on storage, but pay $100 in transaction fees.
That is the detail that gets people fired.
You have to look at the shape of your data, not just the volume. If you have lots of tiny files that you touch often, keep them hot.
And then there's rehydration. We mentioned this with archive.
Moving data costs money. If you move data from cool to hot, you pay a read fee from the cool tier and a write fee to the hot tier. You get hit on both sides.
And let's not forget georeplication.
Right. If you are copying data from the US to Europe for that redundancy we talked about, you are paying a per gigabyte cost for that transfer across the network.
So if you aren't careful, you could engineer a system that is incredibly resilient and redundant, but costs a fortune because you're constantly moving massive files back and forth.
Exactly. Which brings us back to the mission of this deep dive. It's about balance.
So what does this all mean for someone listening who might be staring at a hard drive full of data right now?
It means that Azure Blob Storage isn't just a digital hard drive. It's a configurable system. Success requires knowing the lifestyle of your data.
Is it a viral video? Or a tax record from 2015 archive?
Correct. If you treat all data the same, you lose. Effective configuration means you are engineering a system where the data manages itself through lifecycle rules.
It stops being a junk drawer and starts being a library.
A self-cleaning library.
I like that. Before we go, I want to leave listeners with a thought that struck me when we were discussing the archive tier.
Go for it.
We've built a system where the cheapest place to keep our history, our old photos, our old documents, is in a place where we can't see them instantly. It takes 15 hours to get them back.
Digital purgatory.
In a world that runs on dopamine and instant clicks, if the data is offline, does it effectively cease to exist?
Out of sight, out of mind.
If I have to wait 15 hours to see a photo from 10 years ago, am I just not going to look at it? Are we building a digital memory hole just to save a few pennies per gigabyte?
That is a very philosophical question for a technical architecture. It definitely adds friction to memory.
Something to mull over as you configure those lifecycle policies. Maybe keep the good stuff in the cool tier so you can actually enjoy it.
I think that's sage advice.
Thanks for diving in with us today.
A pleasure.
See you next time.